Welcome to Month 4 of the DevOps Engineer track. Month 1 built your CI pipeline. Month 2 secured the container images that pipeline produces. Month 3 deployed those images to Kubernetes. Today, you provision the infrastructure that runs the cluster itself. Infrastructure as code is the practice of managing servers, networks, storage, and managed services through version-controlled source files rather than manual console clicks. By the end of today, you will have one module set that deploys the Bistec Mart platform across 3 environments, Dev Stage and Prod, with shared remote state, concurrent-apply locking, and a drift detection CI job. We use OpenTofu as the default, a community fork of Terraform maintained by the Linux Foundation under MPL 2.0. Every Tofu command in this session has an identical Terraform equivalent. The HCL you write today works on both. Let us start with a problem everyone in DevOps either has experienced or will. Your team needs to spin up a new environment for a customer demo. Someone SSAs in, runs some commands, edits a security group, installs Nginx, and the demo works. 2 weeks later, production is misconfigured in a way that exactly matches what was manually changed on staging. No one can trace why. No record exists of what changed. This is configuration drift, and it is the primary reliability risk in teams that manage infrastructure manually. IX solves 3 problems simultaneously. Documentation. The infrastructure definition is the documentation. It is always current because if you change infra without changing the code, drift is detected. Repeatability. Running the same IX against a fresh environment produces an identical result every time. Auditability. Every infrastructure change goes through a pull request. Who changed what? When, why, and who reviewed it. If your infrastructure is undocumented, unrepeatable, and unauditable, you are one bad day away from a major incident. IC breaks all 3 simultaneously. In August 2023, HashiCorp changed Terraform's license from MPL 2.0 to the Business Source License, BUSL 1.1, which restricts commercial use by competitors. In response, the Linux Foundation launched OpenTofu, a community fork of Terraform from before the license change, maintained under the original open source license. OpenTofu is now at version 1.7 and has its own feature additions. For this track, we default to OpenTofu. The HCL you write is identical on both tools, and provider compatibility is shared. The Kubernetes, Helm, and AWS providers work with both. When you see Tofu in the slides, mentally substitute Terraform if you prefer. The commands are interchangeable. What matters is the skill of writing and managing HCL, not which binary runs it. HCL, HashiCorp Configuration Language, has 5 building blocks you will use constantly. A resource block declares a piece of infrastructure you want to exist. The type determines which provider manages it. The name is local to your configuration. Together, they form the resource address used in state commands and cross-references. A data source is a read-only reference to existing infrastructure. You are querying it, not creating it. Data sources are evaluated at plan time before resources are created. A variable is the input interface of a module. Variables are how you parameterize HCL. They have a type constraint and an optional default. Variables without defaults are required. OpenTofu will prompt unless you provide them via TFRs files or environment variables. Locals are intermediate computed values that simplify repeated expressions. A local is computed once per module invocation and cannot be changed by the caller. An output is the export interface of a module, what it exposes to its caller. Root module outputs are printed to the terminal at the end of Tofu apply and stored in state. The mental model. Variables are parameters, locals are local variables, outputs are return values. A module is a function. This is the most important footgun in all of HCL. Get this wrong, and you will destroy production infrastructure by accident. Count creates n copies of a resource using integer indexes 0, 1, 2. The problem, if you remove an item from the middle of the list, everything above it shifts down. Terraform sees this as destroy and recreate for every shifted resource. In a production VPC, that cascades into an outage. For each uses stable string keys from a map or set. Each resource instance has a meaningful name, e-west-1, rather than index 0. If you remove one item, only that item changes. Everything else is untouched. The rule, use for each for anything you might need to add, remove, or reorder. Reserve count for the 0 or 1, conditional pattern only, count var.create. 1, 0, where index drift is impossible, because there is at most one item. Look at the two code examples on this slide. The top example with count is the footgun. The bottom example with for each over a map of objects is the correct pattern. The operational difference is enormous. The state file is the most important artifact in your OpenTofu workflow. When you run tofu apply, OpenTofu writes every resource it manages into a JSON file called Terraform tf-state. This file is the source of truth for what OpenTofu believes exists. On the next tofu plan, OpenTofu reads the state, calls provider APIs for the current real-world state, and compares both against your HCL to show the diff. 3 rules. First, never commit state files to Git. State files contain sensitive values, database passwords, API keys, private IP addresses. A committed state file is a secret leak that persists in Git history even after the file is deleted. Second, never edit state by hand. The JSON structure is internal and undocumented. Use tofu state mv to rename a resource, tofu state arma-m to remove one from tracking without destroying it, and tofu import to bring an existing resource under management. Third, treat the state file as a secret. Remote state in an S3-compatible bucket with encryption at rest, access controlled, never printed to CI logs. This is not optional for production environments. The most dangerous IAC command is tofu apply, auto-approve. Never run it in production. Tofu plan examines the current state and desired state and produces a diff. By default, the plan is printed and discarded. If you then run tofu apply, it computes a new plan against the current state, which may have changed since you ran plan. The safe pattern, tofu plan out plan.tf plan saves the plan as a binary artifact. Tofu apply plan tf plan executes exactly that saved plan. No reevaluation, no surprises. The artifact is cryptographically bound to the state at plan time. In CI, the validation stage runs tofu fmt check, tofu validate, and tflint before the plan. Format check catches style drift. Validate checks syntax and provider schema. tflint catches anti-patterns like count over collections. After validation passes, tofu plan out plan tfplan runs. A human approval gate separates the plan from the apply. Tofu apply plan tfplan runs after approval. This is the production-grade ESC workflow. The detailed exit code flag matters for automation. Exit code 0 means no changes. Exit code 1 means error. Exit code 2 means changes present. Your drift detection CI job uses exit code 2. Modules are the unit of reuse in OpenTofu. A module is a directory of TF files with defined inputs and outputs that you call from a parent configuration using a module block. The public API of a module has 2 parts. Variables are the inputs. Outputs are the return values. This is the module's contract. Callers depend on it, and changes to it can break callers. Semantic versioning governs this contract. Version 0 signals instability. Breaking changes can happen at any minor bump. Version 1 and onwards signals stability. Major bumps for breaking changes, minor bumps for new features, patch bumps for bug fixes. Adding a new required variable with no default is a breaking change, major bump. Adding an optional variable with a default leaves callers unaffected, minor bump. Module sources can be a local path for development, a Git URL with a version reference for team-shared modules, or the public registry. For today's lab, we use local paths. For production team modules, Git with pinned version references is the standard. A module with 40 inputs is almost always a sign it covers two separate concerns. Keep modules small, single-purpose, and with minimal stable APIs. Now you build. For the next 40 minutes, you will author 3 modules that together provision the Bistec MART platform, the network module, VPC subnets, and security groups via local stack. Use for each over a map of subnet definitions, not count. Your subnets should be addressable by name. The data store module, an S3 bucket for build artifacts, and an RDS parameter group. Expose only what the root module needs. Do not leak internal resource IDs that callers have no use for. The K8's platform module, a Kubernetes namespace and a Helm release for the catalog chart from month 3. Use the Helm provider, not local exec running Helm commands. Provider-managed resources are tracked in state. Local exec outputs are not. Wire all 3 in env's dev main tf. Run tofu init, review the plan carefully, then apply. Your first successful apply should show resources created and 0 errors. 2 habits to build right now. Read the plan before applying. And if the plan shows a destroy you did not expect, stop and investigate before proceeding. Part 2 introduces remote state, storing the state file in a shared, encrypted, access-controlled backend rather than on your local file system. Step 5. Configure the S3 backend block pointing at Minio. The key settings are endpoint pointing at your Minio instance. Force path style true for Minio's S3 compatible API, and the skip flags to bypass AWS-specific credential validation. Step 6. Configure DynamoDB equivalent locking via local stack. State locking ensures only one apply runs at a time against a given state file. Without locking, 2 simultaneous applies can corrupt state. Step 7. Migrate local state to the remote backend with tofu init migrate state. After migration, the local TF state file should be empty or absent. Your state now lives in Minio, accessible to your whole team. Step 8. The locking demo. 2 participants start tofu apply simultaneously against the same environment. One succeeds. The other sees the error. Error acquiring the state lock. That error is correct behavior. It protected you from concurrent mutations. This is what remote state locking looks like in practice. Part 3 builds the directory structure that keeps dev, stage, and prod infrastructure separated and independently manageable. Step 9. Create env's stage and env's prod alongside env's dev. Each has its own main TF calling the same modules, its own backend.tf with a unique state key, and its own Terraform.tf vars with environment-specific values. Step 10. Write per end TF vars with real differences. In dev, the catalog replica count might be 1. In prod, 3. Instance sizes differ. Retention policies differ. These are not just label changes. They reflect genuinely different operational requirements. Step 11. Run tofu plan for each environment. You should see meaningful differences reflecting the TF vars. 3 environments, 1 module set, 3 distinct infrastructure configurations. Step 12. Drift detection. While the cluster is running, edit a Kubernetes config map directly with kubectl edit. Then run tofu plan in the dev environment. The plan will show a change. OpenTofu detected that live state diverged from your HCL. This is drift, and detecting it is the topic of the next slide. OpenTofu workspaces and directory per environment are both patterns for managing multiple environments. This track uses directory per env. With workspaces, you stay in the same directory and run tofu workspace select prod before applying. State files are separate, but the backend configuration is shared. The failure mode: forgetting to switch workspaces before applying. A missed workspace select, followed by apply, touches the wrong environment. In a CI system with shared runners, workspace selection is a race condition. With directory per env, you must physically cd env's prod and run tofu init before you can apply. The working directory is the environment. Mistakes require more deliberate effort. The backend is also separate per environment, different state paths, different access controls, different blast radius. Use workspaces for genuinely identical ephemeral environments. Preview stacks, feature branches. Use directory per env for dev stage, and prod where real configuration and risk diverge. Drift is the gap between your HCL definition and the live infrastructure. It happens when someone edits a resource via the cloud console, when a cloud provider modifies something automatically, or when an external process updates a resource directly. Drift is normal. The question is whether you detect it quickly and have a clear remediation path. The drift detection pattern: a daily CI job runs tofu plan detailed exit code for each environment. Exit code means no drift. Exit code 2 means the plan has changes. The live state diverged from your HCL. The CI job opens a GitHub issue with the plan diff, so the team can review what changed and decide how to respond. 3 remediation strategies. Reconcile to Git, run tofu apply, and let OpenTofu restore the desired state. Use this when the manual change was accidental or unauthorized. Adopt the live change, update your HCL to match what exists, then run tofu import if needed. Use this when the manual change was intentional and correct. Accept the drift, add lifecycle. Ignore changes to the resource for the drifted attribute, with a comment explaining why. This is the last resort. The lifecycle ignore changes abuser is a real anti-pattern. Teams that add ignore changes to every resource because someone keeps manually adding tags are hiding real drift. The correct fix is to codify the tag in HCL, not to stop looking. EEC architecture review has a different character than code review. You are evaluating infrastructure decisions that are expensive to change, module boundaries, state layout, locking strategy, not just syntax. 4 questions to ask in any ISC module review. Does the module's input set represent a coherent single concern, or is it doing 2 jobs? A module with 40 inputs usually covers 2 separate concerns and should be split. Are the outputs consumer-driven? Does each output serve a specific caller need, or are they leaking implementation details? Can you upgrade the module independently from the root configuration? And is the state layout clearly separated so an accidental apply in one environment cannot touch another? When to put logic in HCL versus a wrapper script. If the logic can be expressed in HCL, put it in HCL. It is tracked, plan diffable, and auditable. If it requires something OpenTofu cannot model, a one-time database seed, a certificate activation, use local exec and document why. If you find yourself writing complex bash inside local exec, a separate pipeline stage is probably cleaner. 4 deliverables, 25 points each. Deliverable 1, 25 points. 3 reusable modules, network, data store, and Key8's platform, each with versioned inputs and outputs. For each over a map of subnets. Provider and OpenTofu versions pinned in versions.tftf. Validation blocks for at least 2 inputs. Outputs are consumer-driven, not implementation leaking. Deliverable 2, 25 points. The multi-environment layout, envs dev, env stage, envs prod with separate state keys, and real per env differences in TFRs. Locking proven via transcript of 2 concurrent applies where one is blocked. A makefile or shell wrapper preventing accidental cross-env apply. Deliverable 325 points. The drift detection workflow. A CI job running Tofu plan, detailed exit code daily, opening a GitHub issue on exit code 2 with the plan diff, plus a runbook covering all 4 remediation patterns, and an escalation path for unresolvable prod drift. Deliverable 425 points. The module README for K8's platform, purpose, copy-paste runnable usage example, inputs and outputs tables matching the actual module, versioning policy, at least 2 examples, generated by Terraform docs so it stays current as the module evolves. Common mistakes to avoid: workspaces instead of directories, count over collections, secrets in TFVARs, state committed to Git, local exec for Helm instead of the Helm provider. 6 milestones before month 5. Replace local stack with a real cloud account for the dev environment. Same modules, 2 line changes in the provider and backend configuration. This validates that your modules work against real cloud APIs, not just the mock. Add Terraform docs to auto-generate the module README. A README that drifts from the module is worse than no README. Wire Terraform docs into a pre-commit hook so the documentation stays current automatically. Add tflint and Chekhov or tfsec to your CI pipeline. Tflint catches HCL anti-patterns. Chekhov scans for security misconfigurations, public S3 buckets, open security groups, missing encryption. These gates prevent IAC-shipped vulnerabilities. Wire Atlantes in front of your repo. Every pull request that touches TFTF files gets an automatic Tofu plan comment. Approval plus merge triggers Tofu apply. This is the gold standard for Team ISC. No manual applies from laptops in production. For reading, Terraform, Up and Running by Yevgeny Brickman, chapters 4 through 6. And the OpenTofu documentation at opentofu.org, more current than many third-party references. Take a moment to recognize what you built today. You started this morning with a Kubernetes cluster running Bistec Mart. You are ending with the infrastructure that runs that cluster, codified in HCL, deployed across 3 environments, with shared remote state, concurrent-apply locking, and a drift detection CI job. 4 months in, CI pipeline, secure container images, Kubernetes deployment, infrastructure provisioning. 1 more layer of control added each month. That is the full application delivery stack, built from scratch by you. Month 5 is observability with Prometheus, Grafana, and Loki. You will instrument the infrastructure you provisioned today, metrics, dashboards. By month 5, the question shifts from, is it running? To how well is it running, and who gets paged when it is not? That is the full DevOps feedback loop. Great work today. See you in month 5.